Okay, so this is a new chapter on curve fitting and interpolation. There are two types of things we're interested here. One is, let's say that we are given some data points like this. Okay, this could come from an experiment, and your goal is to try to fit a curve through these points. So if you have 4 points, you probably want to do a quadratic, a cubic polynomial. So this curve passes through all the points. Okay, and then the x's are data points. Okay, so sometimes you want to do what is known as an exact fit so that the curve passes through all the points. Okay, why we'll do it, we'll just come to that in just a bit. There's also an inexact fit. So now I'm going to throw in more data here. So there is an underlying function f of x we need to find. Now you see there is a problem here in the way this data comes. For this value of x, we see that there are 2 data points. Okay, they're exactly one top of each other. Here's another place where there's a problem. Those data points are exactly one of the other. So it looks like it's there's at a given x, there are 2 values of f of x. So if you think of this in real world, you're doing an experiment and you're trying to collect data at a particular independent variable, which is x, and you measure something and you get some data, and then after 5 minutes or 1 day or 1 week, or let's say a friend does the experiment, the same experiment, same x, he or she finds a new data point. Okay, so there are 2 points at the same x. In this case, because it is a real world experiment, you really don't expect that the data would fall like the one I showed earlier. It won't really fall in that nice curve. Here, what we're trying to do here is we're trying to find the best fit line, which sort of explains the trend in the data. So perhaps this line, this curve, is something which captures the trend in the data. Right? And this would be what we call an inexact fit. What it's trying to do is it's trying to minimize the error between the curve and the data points, which are shown in red. Okay, so if you try to put that curve something like this, then you'll miss on a lot of points below, which means that your errors would be larger than it was the line shown in the continuous line shown below, right? Okay, so why are we even trying to fit a line? Well, one of the reasons why you want to fit a line is you want to predict what's going to happen at a point which is not measured, right? So for example, let me just move this around, stop here, and then we fit a line which sort of, or a curve which explains the data. Sometimes we are interested in knowing what happens at a point which is not being measured directly. So we don't have data at this point, and we would like to know what this value is. And so if you have a curve which passes or sort of explains the trend, then you can estimate that. This process of estimating data at a point in between the interval, like anywhere between the points, so between this point and that point, extreme points, is known as interpolation. And if I told you to estimate what would happen over here. Let's call that x2. You can see x2 is nowhere near the data set I collected. So what is happening here? That would be a problem in extrapolation. Okay, so both of them are important. Interpolation is important because let's say that it's expensive to run an experiment to collect data over 5,000 different test cases, right? Because what you want is probably in between some point, and it's just hard. It's very expensive to collect data. So what you do is you collect data over maybe 100 instances, and you fit a line, and then you sort of predict what will happen in between those points. So you can use then. So it really decreases the number of data collection you need to do when you are talking about interpolation. Extrapolation is kind of interesting. You may want to make projections what will happen. So for example, if you want to predict stock prices, how if a commodity is going, the stock is going to go up, that would be a problem in extrapolation. If you have a good model of the system, you could maybe predict what's going to happen tomorrow, in a month's time, a year's time, and so on.